Okay, let us continue the topic. So refractory period is very, very important. Otherwise, the neuron cannot respond to the second stimulus. Why? Because to respond the stimulus, outside more sodium should be there, inside more potassium should be there. But due to this first action potential, what is happening? The condition is reversed. So inside more sodium, outside more potassium are there. Even though the resting potential is having minus 70 millivolts value, minus 70 millivolts capacity, but ionic condition is reversed. Outside more potassium, inside more sodiums are there. So to respond to the second stimulus, all the sodium that entered inside the cell has to come out. All the potassium that left the cell has to come inside. So this will be done during this refractory period. So during this refractory period, sodium potassium active pumps will be active, and due to their function, what will happen? The original condition, that means outside more sodium, inside more potassium, will be again reinstalled. So in this way, after a refractory period only, the neuron can respond to second stimulus, and again it can generate second action potential. So, and in this refractory period, first half of this is called as absolute phase. In this absolute phase, the neuron cannot respond to a second stimulus even if the stimulus is having high strength. Why? Because to respond to the thing, sodiums have to come out of the cell. So that's why in the absolute phase, the neuron cannot respond to the second stimulus, even though it is having a higher capacity or higher strength. So after some period of time, it enters into relative phase in the refractory period. In this refractory period, if the stimulus is having lot of strength, so high strength stimuli, if it is given, it can initiate the second action stimulus. So this is the importance of refractory period. So again, coming. So this is about refractory period and properties of action potential. And coming to the importance of this action potential is that, so this is very, very important for the functioning of neurons or total nervous system. So it is due to the movement of sodiums inside, potassiums outside, and again sodiums outside, potassiums inside. Due to these movements only, nervous system is able to do all these things. It is due to this movement of these sodium potassium ions only we are able to see, we are able to smell, we are able to taste, we are able to hear, we are able to feel the pressure, touch, temperatures, and all these pain, all these things. And it is due to this sodium potassium ions movement only we are able to think, we are able to remember, we are able to take decisions, and we are able to move our muscles, we are able to do all these works. It is due to the activity of the sodium potassium ions moving inside outside, outside to inside, inside to outside. So this is very, very important. And even in the muscle contraction also, we have seen that during the muscle contraction, when the nerve impulse comes to this neuron, and neuromuscular junction is there. In the neuromuscular junction, due to this propagation of action potential, at the end of neuromuscular junction, neuron will release neurotransmitters, and these neurotransmitters, when they are bind to muscle cell, the calcium ions will be liberated from triad system. Then only muscle is able to move the muscles. Muscle is able to contract. So muscle contraction also is directly linked to this action potential or neuron signals. In this way, action potentials are very, very important. And not only in this thing, not only in this neurons, throughout our body, in all the cells, inside the cells and outside the cells, the same condition. Outside more sodium, inside more potassium conditions will be there. So all these things will be maintained as a part of buffering mechanism or maintaining ionic balance. But here in this neurons, okay, here in this neurons, what is happening? When stimulus is given, sodiums go inside. And after the stimulus is withdrawn, potassiums come out. Again, later, what is happening? Sodiums go out and again potassiums come inside. So the movement of sodium potassiums will be seen only in nervous tissue. In remaining tissues, I mean remaining cells, this type of movements is not seen. Even though sodiums, potassiums will be there inside the cytoplasms and outside the cells in the extracellular fluid, but movement of these ions in other tissues cannot be seen. The movement of sodiums entering into the cell during this depolarization stage or phase, and potassiums going out of the neuron in this repolarization stage, and sodiums again going out of the neuron, potassiums coming inside the neuron during this refractory phase. All these ionic movements, sodium potassium ionic movements like this way, in this way, can be seen only in neurons. So it is due to this type of going in out coming out, going in coming out of the sodium potassium movements. It is due to the sodium potassium movements only neurons are able to do their duties. Nervous system is able to do to perform its functions. So this is the importance of action potentials. So I hope you all understood very well this topic. If you have any doubts, we will discuss in next class. Okay.